All right, good morning again. There was a type of problem that we did not take a look at the other day, and I just wanted to talk about those right now. And I just didn't want to overwhelm you. Yesterday, as we looked at these, so hopefully you remember we looked at the other day. We looked at polynomial equations and equations involving radicals and quadratic type equations. Well, there's one other type of equation in this section, and it's an equation involving fractional expressions. So we could have something that looks like this: 3 over x plus 5 over x plus 2 equals, let's say, 2. All right. Now, hopefully, right off the bat, that looks like an ugly problem to you. That's my expectations. You look at that and go, man, that's ugly. And so, but here's the thing. You are going to see problems like this in the future. You're going to see problems like this on the ACT. You're going to see some, and I don't want you to be freaked out by it. Okay, these problems are way too easy for you to have a problem with them. And so what we have to do first is we got to basically look at it as all fractions. And so this is, 3 over x plus 5 over x plus 2 equals 2 over 1. And the only reason I just wanted, just in case this happened to be something other than just a constant like 2, and what I want to do is I want to find the common denominator. Now remember, if I have this x right here and this x plus 2, that does not mean that the common denominator is just x plus 2. Okay, remember, you can't do that. You'd have to go, well, this one is x and that one is x plus 2. And so the only way of finding the common denominator between those two is to multiply them. And so that would mean the common denominator would look more like that. Okay, so that is the common denominator. Okay, would be x plus 2 times x. Now, you could distribute that out. It doesn't really matter. It doesn't make sense to do that, but here's what we're going to do. With that is you can look at this equation and you can multiply both sides of the equation by this common denominator. And we've done that a lot before where we've said, well, we want to work with these fractions by making them all go away. We make them all go away in an equation when we just multiply by the common denominator. So let's do that. So what we'll do is we'll look at this first one. We'll say, okay, so this is 3 over x times x plus 2 times x plus 5 over x plus 2 times x plus 2 times x equals 2 times x plus 2 times x. Okay, and at this point, the whole reason we multiply by a common denominator is to see things get canceled out. We've got an x in the denominator here, so that cancels out with this x. And we're only left with 3 times x plus 2. This one has an x plus 2 in the denominator, and so it cancels that one out. So we have plus 5x equals, and well, nothing cancels out on the other side, so we actually do have to distribute that one. And we would get, what, 2x squared plus 4x. You get 2x plus 4, and then multiply both of them by x. You get 2x squared plus 4x. Okay, and at this point, hopefully you recognize that this is really becoming basically a quadratic. So you'd have 3x plus 6 plus 5x equals 2x squared plus 4x. And whenever we're doing quadratic problems, our goal is always set it equal to 0. So we always want to get everything over to one side. So I'm going to move everything over to this side so that way the x squared term stays positive. So I'm going to say 2x squared. Let's see, I've got 4x. I'm going to subtract 3x, which would get me down to 1x. And then I'm going to subtract 5x, which is going to get me to negative 4x. And I'm going to subtract 6, and all of that equals 0. And at this point, I remember when you're factoring a quadratic that has a term out in front of the x squared, you have to say, well, that number times the negative 6. So 2 times negative 6 is negative 12. Factors of negative 12 that add up to be negative 4 would be negative 6 and 2. So I'm going to say 2x squared plus 2x minus 6x minus 6 equals 0. So therefore, I'd have 2. You can factor out of these first two terms, you can take a 2x out, which would leave me with x plus 1. Out of the next two terms, you take a negative 6 out, which leaves you with x plus 1. So then you're at 2x minus 6 times x plus 1. And all of that equals 0. And just like we've said before, if you have two things multiplied together that equal 0, then you set them equal to 0. You say, okay, I'm tired of writing in red. You say 2x minus 6 is equal to 0, and x plus 1 is equal to 0. All right, so you add 6 to both sides. 2x is equal to 6. Divide both sides by 2. X is equal to 3. On this one, just subtract 1 from both sides, and x is equal to negative 1. Now, it's always worthwhile to take those answers and plug them back into the top and make sure they make sense. So we have the two answers, x equals 3 and x equals -1. All right? And so if I plug in a 3 right here and right here, well, 3 over 3 would be 1. And then 5 over then 3 plus 2 is 5. So 5 over 5 would be 1. 1 plus 1 is 2. Well, that's good. Okay, and the other answer is -1. Well, if I plug in a -1 at that first one, then I'd get -3. If I plug in a -1 at the second one, -1 plus 2 is 1. 5 over 1 is 5. So I'd have -3 plus 5. Again, that's equal to 2. So both of these answers are acceptable and good. Okay? All right. What I want you to try a problem exactly like that. We're going to start with a fractional expression, and you're going to see if you can work it out. Okay? So I'll give you the problem. We'll start with something like this. How about 10 over m plus 5 plus 15 equals 3m. All right. Okay. We're going to pause the video right here, let you guys get a start on it. It should take you about 3 minutes, 4 minutes, and then we'll look at it together. Okay, and we're back. All right, so with this problem, they only have one fraction, so that makes it a little bit easier. So the common denominator is just the denominator of that fraction right here. So I have to multiply everything by that m plus 5. So I multiply everything on this side by m plus 5, multiply everything on this side by m plus 5. And what that ends up looking like is m plus 5 times 10 over m plus 5 plus m plus 5 times 15 equals 3m times m plus 5. Make sure I'm not losing anybody. Obviously, on this first one, these cancel out. This cancels out with, I like to cancel out in red. This cancels out with this. Okay, nothing else cancels out because nothing else had a fraction in it. So the only thing I'm left with on this first one is 10 plus, and distribute that 15. You get 15m plus 15 times 5 is 75 equals 3m times m is 3m squared, and 3m times 5 is 15m. Okay, so I'm going to move everything to this side, and that's going to give me 3m squared. Now, I've got a positive 15m, but I'm subtracting 15m from both sides. I want to make sure that's right. 15m, yeah, and 15m. That's right. So I'm going to subtract 15m from both sides, so that's going to disappear, and then I'm just going to have minus 10 equals 0. Okay, I hope I'm not making a mistake on this one, but it's possible. If I am, I don't see it. Okay, so this is what I have. 3m squared minus 10 equals 0. All right, at this point, you know, there's a couple different ways of looking at this. You could just go ahead and bump the 10 to the other side and say 3m squared is equal to 10. Divide both sides by 3. M squared is equal to 10 thirds, and therefore m is equal to plus or minus 10, square root of 10 thirds. Now, hopefully you got the same answer. And I know that was an odd one. We kind of always want things to come out cleaner and nicer, but sometimes they don't. Okay, let's try one more, and then I'll let you get started on something else. So I want you to do this one. How about 10 over x minus 12 over x minus 3 plus 4 equals 0. All right? Okay, I'm going to let you guys work on this one for about 3 or 4 minutes. We'll pause the video right here, and then we'll come back together and do it. Okay, let's take a look at it. For this one, let's see here. The first thing I see is the common denominator. The common denominator is x times x minus 3. Okay? Because you got to multiply those denominators. And so then I go through and I multiply everything by x times x minus 3 times 10 over x minus x times x minus 3 times 12 over x minus 3 plus 4 times x minus 3 equals 0. Because 0 times x minus 3 is just still 0. Okay, on this side over here, on the first one, the x's cancel out. The next one, the x minus 3's cancel out. And the last one, nothing cancels out. Okay, so I get 10 times x minus 3 minus 12x plus 4x squared. And then let's see, 4x minus 12x equals 0. Distribute on this first one, you get 10x minus 30 minus combined like terms, 24x plus 4x squared. Now go ahead and put them all in, like, descending exponential order. So you get 4x squared. 10x minus 24x would be minus 14x minus 30 equals 0. Okay, so if I say 4 times negative 30, 4 times negative 30 is negative 120. Factors of negative 120 that sum negative 14, well, that would be negative 20 and positive 6. Now, maybe you did this by completing the square, but I happen to know how to factor it. So I'm going to say, okay, so this is 4x squared minus 20x plus 6x minus 30 equals 0. Factor these first two terms, take a 4x out, and I get 4x times x minus 5. On the next one, take 6 out, you get x minus 5 equals 0. So you're left with 4x plus 6 times x minus 5 equals 0. So then I have 4x plus 6 equals 0, which would be 4x is equal to 6, or x is equal to 6/4 or 3/2. The next one, you get x minus 5 is equal to 0, so therefore x is 5. Okay, hopefully you got those two values. All right. What I'm going to do is I'm going to have you practice some of the problems that we've been working through like this and others, and then I'll come back in and make sure we're doing those right. Okay? We'll see you in just a little bit.